Today we're on Lesson 7 of Unit 12. We'll be covering pages 435 and 436. Be helpful if you had a highlighter and a calculator. So at the very top here, we have a box containing a summary of all our formulas. The probability of not A is equal to 1 minus the probability of A. Probability of A given B equals the probability of A and B over the probability of B. The addition rule, probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. The multiplication rule for independent, if two events are independent, then the probability of A and B would equal the probability of A times the probability of B. And then events A and B are independent if and only if the probability of A and B equals the probability of A times the probability of B, and the probability of A given B would equal the probability of A. Now, our first example, we have the scenario where a car is brought to a repair shop for a service, and we have three probabilities. The probability that it will need the transmission fluid replaced is 0.38. The probability it will need the brake pads replaced is 0.28. And the probability it will need both the transmission fluid and the brake pads replaced is 0.16. So let the event that a car needs the transmission fluid replaced be T, capital T, brake pads replace capital B. So what are the values of the probability of T, that it needs the transmission fluid replaced? That is 0.38. And the probability brake pads replace is 0.28, and the probability of both transmission fluid and brake pads replace is 0.16. Use the addition rule to find the probability that a randomly selected car needs the transmission fluid or the brake pads replaced. So this would be the probability of transmission or brake pads would equal probability of T or B equals probability of T plus the probability of B minus the probability of T and B. Substitute in the values. 0.38 plus 0.28 minus 0.16. 0.66 minus 0.16 is 0.5. Example 2. Josie will soon be taking exams in math and Spanish. She estimates that the probability she passes math exam is 0.9 and the probability she passes the Spanish exam is 0.8. She is also willing to assume that the results of the two exams are independent of each other. The probability of A and B, when they're independent, would equal the probability of A times the probability of B. Using Josie's assumption of independence, calculate the probability that she passes both exams. So assuming they're independent, the probability that she passes math and also Spanish would equal the probability she passes math times the probability of passing Spanish. 0.9 times 0.8 is 0.72. Find the probability that Josie passes at least one of the exams. Hint, passing at least one of the exams is passing math or Spanish. So the probability of passing math or Spanish will equal the probability of passing math plus the probability of passing Spanish minus the probability of passing math and Spanish. 0.9 plus 0.8 minus the 0.72 we found above. 1.7 minus 0.72. 0.98. Next, we have disjoint and mutually exclusive. Two events that have zero outcomes in common. Zero or no outcomes in common. They are considered mutually exclusive or disjoint. So if A and B are disjoint events, if they have nothing in common, no outcomes in common, no overlap, then the probability of A or B equals the probability of A plus the probability of B. It's just that the minus the probability of A and B is 0. So we would just be subtracting 0 from that. So disjoint or mutually exclusive events, two events that have no outcomes in common. So if the events A and B are disjoint, the Venn diagram looks like this. There is no overlap. There is no and. Another way of describing disjoint events is by saying that they cannot both happen at the same time. Thus, when two events A and B are mutually exclusive, then the probability of A and B is 0. For example, if a die is rolled once, then the result is even, and the result is a 5 are disjoint. They have nothing in common. Even is a 2, 4, or 6, and 5 have nothing in common. They are disjoint. Since even and 5 cannot both happen on a single roll. But the events, the result is even and the result is greater than 4 are not mutually exclusive, since getting a 6 results in both events occurring. Example 3, we have a pair of dice is rolled. Two possible events are rolling a number greater than 8 and rolling an even number. So we want to think of a number, rolling a number greater than 8 and rolling an even number. Are these two events mutually exclusive? So we're looking at the sum, right? So here are all the possible outcomes. You could get a 5 on the one die and a 4 on the other, so the outcome, the sum is 9. Greater than 8, well, let's draw a Venn diagram. So I'm going to say greater than 8 and rolling an even number. Okay, so our even outcomes, we've got 2, 4, 6, 8, 10, and 12. 2, 4, 6, 8, 10 is greater than 8 and also even, and 12 is greater than 8 and also even. Now greater than 8, we have 9, 10 is there, 11, and 12. So are these events mutually exclusive? No. They are not mutually exclusive. Since 10 and 12 are results in both. Our next example, a pair of dice is rolled. Two possible events are rolling a number less than 5 and rolling a number which is a multiple of 5. Are these two events mutually exclusive? So less than 5 is our 1, 2, 3, and 4, and rolling a number which is a multiple of 5 are 5 and 10. So yes, these are mutually exclusive. Example 5, using the addition rule for disjoint events. We have a set of cards. A set of 40 cards consists of 10 black cards showing squares, 10 black cards showing circles, 10 red cards showing X's, and 10 red cards showing diamonds. A card will be selected at random from the set. Find the probability the card is black or shows a diamond. So we want the probability, I'm going to use black or diamond. Well, there are no black cards that show diamonds, so these events are mutually exclusive. So this would equal the probability of black plus the probability of diamond. And if we think of minus the probability of black and diamond, that's 0. Probability of black is 20 out of 40. And the probability of diamond is 10 out of 40. And minus probability of black and diamond is 0. So this is 30 out of 40. And that wraps up Unit 12 and Lesson 7. Thank you for your attention.